I'm Dr. Sohaila Chima. I'm the Assistant Dean with the Institute for Population Health here at Weill Cornell Medicine-Qatar. I would like to welcome you to another session of Health and You, the Community Wellness Series. This is the third month that we are actually doing this session. And as you all may know, who may have attended in the past, the overall goal of the series is to create community awareness about health and disease. And the ultimate objective of the series will be to enhance self-care, to reduce suffering, improve the quality of life, and increase healthy longevity. So just some housekeeping, your cameras and microphones are turned off. Use the question and answer feature to type any questions or comments you may have. Questions will be addressed at the end of the session. And just a reminder, this is not a CME CPD activity, so no certificates of attendance will be issued. So as you all may know, when you all registered today, the speaker for our talk is Dr. Shahrad Taheri, and he will talk about things that go bump in the night, impact of sleep on health. It is my honor and privilege to welcome Dr. Taheri to the podium. Dr. Taheri is Professor of Medicine at Weill Cornell Medicine-Qatar. He graduated in medicine from the Medical College of St. Bartholomew's Hospital, London University, and then obtained his PhD in neuroendocrinology from Imperial College London. He has trained in clinical medicine and research in London and Bristol in the UK and at Stanford, California, where he was a Howard Hughes Research Associate. Dr. Taheri has been a member of the Clinical Care Committee at World Obesity. He is Chair for Research at the National Diabetes Strategy Ministry of Health, Qatar, and Chair for Research at the Qatar Metabolic Institute at Hamad Medical Corporation. Dr. Taheri is Assistant Chair of Medicine at HMC. He has led the Medical Weight Management Service there. He has supported the development of the National Obesity Treatment Center at HMC and contributed to national and local guidelines on obesity in the UK and Qatar. Dr. Taheri's research interests include human intervention and population studies and investigations into the relationship between sleep, obesity, and metabolic hormones. Dr. Taheri has published extensively and serves on the editorial board of several journals, including International Journal of Obesity and PLOS One. Dr. Taheri, a very warm welcome to you. Over to you.
Okay, welcome everyone. Thank you for that wonderful introduction. And I'm delighted to be with you today talking about sleep and why sleep might be important and how sleep disorders may affect people in different ways and give you an idea about sleep disorders. So I'm going to talk to you a little bit about the physiology of sleep, how we measure it, what it means, talk about some interesting sleep disorders that might give you an idea about what happens when we sleep, and then examine the impact of sleep on health and how important it can be. Now, we know that children spend about half their life sleeping, and adults spend about a third of their life sleeping. So what is this sleep about? So hopefully I can manage to give you an idea about how sleep can be important. It's important to realize that actually sleep in history was very much related to the idea that when we go to sleep, we actually die in a way. And that's why Hypnos, which is the god of sleep, was brother of Thanatos, which is the god of death. And here Hamlet puts it very nicely: to die, to sleep no more, to die, to sleep, perchance to dream. For in that sleep of death, what dreams may come. So you can see that the belief was that when we go to sleep, we just die and we wake up again, we get reborn again in the morning. So very much in history, nobody had an idea what sleep was about, and it's very much related to the myths and mythology and what was happening during sleep. There's this general belief that sleep is a waste of time. So here is Thomas Edison, as you know, is the father of 24/7 society, the electric light bulb. It says sleep is an acquired habit. Cells don't sleep. fish swim in the water all night. Even a horse doesn't sleep. Man doesn't need any sleep. And here's Isaac Asimov, who is the science fiction writer, saying, I never use an alarm clock. I can hardly wait until 5 a.m. In the army, I always wake up before Reveille, which is the trumpet sound. I hate sleeping, it wastes time. But actually, these people were wrong. So Edison was completely wrong in the sense that there are activity cycles within cells. Fish do sleep, horses do sleep, and sleep is absolutely essential. And here to just show you, here's a fish, which you can see swimming around very nicely, that Edison said fish don't sleep. And you can see it actually, it's not swimming all the time. And as time goes by, what happens with fish, they drift to the bottom of the aquarium or pool and they go to sleep. This fish is actually a model of sleep. You can see it drifting very nicely. It's going into various sleep episodes. And if you do measure its brain activity, it will show it is actually sleeping. Now it's awake, it's swimming around, very active. This is what fish do. And then they go to the bottom and they go to sleep. So hopefully this fish should get to the bottom and start going to sleep. So Edison was wrong about sleep. And in fact, the story goes that Edison lost his first job because he slept on the job. And he also had a cubbyhole in his lab where he used to go to sleep, which was kept secret. So Edison actually really did value sleep, although what's happened with his legacy is that we have this 24/7 society that we don't sleep as much as we're expected to do. So here's this fish now going to the bottom, and you can see it nicely going to sleep. So fish do sleep. Dolphins swim in the water all night, but they sleep. They have what's called hemispheric sleep, where one side of the brain sleeps while the other side is doing the swimming, and it switches around. Excuse me. So Edison was wrong. So Hamlet said very nicely, there's nothing either good or bad, but thinking makes it so. It's how you look at it that determines how important sleep is. And Alan Rechtshaven, who's one of the sleep researchers, he made a statement: sleep does not serve an absolute vital function. It is the biggest mistake the evolutionary process made, because it's seen in almost all organisms, and it's one of the most important aspects of our lives. So Rechtshaven did this experiment to see, is sleep really that important? So this is not an experiment that we do these days, but basically this TSD is a totally sleep-deprived rat. And this is the control rat, which is supposed to sleep normally. What happens is when the totally sleep-deprived rat goes to sleep as measured through its brain activity, the computer turns this wheel and this rat lands in the water and wakes up. So in a way, every time this rat goes to sleep, it ends up in the water, ending up awake, so it's totally sleep-deprived. The control rat can sleep when the TSD rat is awake. So the control rat is partially sleep-deprived, but it's less sleep-deprived than the totally sleep-deprived rat. And what Rechtshaven noticed that if you look at these rats, if you look at the survival time, the mean survival is about 21 days. So these rats actually died because of total sleep deprivation. And when you looked at them after or near death, they showed extreme debilitation by appearance. The temperature was low. They had edema, which is fluid swelling of the pores. They had motor weakness. That means they couldn't move around, and they were ataxic. They had lack of balance, and they couldn't generate a high EEG amplitude. That means their brain wasn't active enough to be able to generate a brain electrical activity. They had enlarged adrenals showing high stress, and they had burnt all their bridges in terms of burning all their body fat. So Rechtshaven, through this experiment, demonstrated that actually sleep is vital to survival. So now we need to really think about sleep as one of the biological needs. So we have food, water, sleep, but actually we can go without water for 48, 72 hours, or a little bit longer, depending on your hydration status. We can go without food for months, but we cannot resist sleep. And this is why sleep is so important, because it's almost impossible to resist sleep. Even with medication, people that keep them awake, people cannot resist being sleep deprived because they go to sleep. Now, how is our sleep regulated? Our sleep is regulated by an area of the brain called the hypothalamus, which is this area on the MRI, magnetic resonance imaging scan. And the hypothalamus is about a 3 cubic centimeter part of the brain. It's not part of your thinking process, but actually it regulates every part of your body. So the hypothalamus regulates the hormones, water balance and thirst, autonomic function, your sympathetic and parasympathetic activity, which regulate your heart rate and blood pressure, temperature regulation, appetite, how much we eat and how hungry we are, our emotions, our reproduction, our memory, as well as our circadian rhythms, which determine when we should be awake, when we should be asleep, when we should release some hormones, when we should eat. And of course, it's also important in sleep. And that's why sleep is related to all these different areas that the hypothalamus regulates. And the reason we know why the hypothalamus is important in sleep is through this observation by van Economo. Now, van Economo observed in the early 20th century, there was this epidemic called the Encephalitis lethargica epidemic, a little bit like the pandemic going on now. But what it did, what it affected younger individuals. And it resulted in several neurological observations here. So he observed some of the brains and he realized that those who had damaged the posterior hypothalamus were asleep all the time. Therefore, the posterior hypothalamus was important in wakefulness. And those who had damaged the anterior hypothalamus were awake all the time. So it's important in terms of sleep. So we have different areas of the brain that determine how we regulate our sleep, and the hypothalamus is divided into these areas that tell us when to go to sleep and when to be awake. Some of these individuals who had encephalitis lethargica developed Parkinson's disease, and you may have read the book Awakenings by Oliver Sacks, or seen the film with Robert De Niro, Robin Williams, where a whole group of them developed Parkinson's disease and were given L-DOPA, which allowed the Parkinson's disease to go away. So van Economo showed very nicely the hypothalamus is the center of not only regulating many aspects of our body, but also sleep. Now, sleep is regulated by two factors, what we call two processes. And one process is called process S, which is like an appetite. What happens is the longer we stay awake, the S level goes up. As you can see, that means we develop what is called a sleep debt that we need to pay off. And if that sleep debt is high enough, we go to sleep, which is the black area here. However, as you can see, as we go through the day, our sleep debt is going up. So by the time we get to around the afternoon time, we should be asleep because we have a sleep debt. That's why we need another signal called a circadian signal, which is called process C. And process C tells us this is not the time to be asleep. So in the afternoon, it tells us to be awake. And when the process S is high, that means we have a high sleep debt. And process C is low, that's when there's a permission, what we call permissive effect, that allows us to go to sleep. As we go to sleep, we pay off this sleep debt, and a circadian signal builds up, so we can be awake again. Now, this causes problems when the two are not aligned. So when the circadian system is not aligned with the sleep debt system, which is process S, that's when we get problems such as shift work and jet lag. So for example, in shift work, in night shift work, people are awake during the night and they want to sleep during the day, but the circadian signal tells them it's the daytime, so they should be awake. So there's this mismatch between the two, and we know that shift work is associated with cardiovascular disease, diabetes, and metabolic abnormalities. Also, during jet lag, what happens is there's a sleep debt that occurs, but the circadian timing is different because the time from the origin is different from time from destination. So the body is getting a different circadian signal. And when there's misalignment between the two, that's when jet lag occurs. Now, it takes a few days for the two processes to align together, and that's why jet lag takes a few days to recover from. Now, how do we evaluate sleep? We can ask people, take a sleep history and ask them, well, how did you sleep last night? What are the problems with your sleep? We can use certain questionnaires. Some people can keep diaries to tell you what time they go to sleep and what time they wake up. We can use accelerometers. Many of you have these watches that you wear, health watches that measure your sleep, that tell you about your sleep. They're very good at telling you about the timing of sleep and how much you slept, but they're not so good at the idea of telling you about depth of sleep. Or you could do something called polysomnography, which is the gold standard of measuring sleep. Now, polysomnography was developed by somebody called Hans Berger in 1952. And basically it means poly means many, somno means sleep, graphy means writings. And it measures your EEG, which is your brain activity through electrodes on the scalp, electrooculogram, which looks at your eye movements, electromyography, which looks at muscle tone. There are sensors that look at nasal and oral airflow. There are chest bands that measure how much breathing you're doing through respiratory effort. Measures of oxygen saturation at the finger. There's electrocardiogram looking at the heart. There's something to look at sleep position, because certain sleep disorders are more common in particular sleep positions. There's a microphone in case you say something funny, and many people do. And there's a video in case you do something funny in your sleep. And this provides a window into the brain as well through the EEG. This is what polysomnography looks like. You can see there are electrodes around the eyes that measure eye movements. There are electrodes on the scalp that tell you about the brain activity. There are sensors looking at nasal and oral airflow. There's a microphone that listens to you in case there's snoring or there's anything else that you might be saying. And when we do the EEG, it was very obvious that actually many different things are happening during sleep, that the brain was actually quite active. So I'll take you through what EEG looks like in a simplified manner. First of all, looking at the bottom line. The bottom line is basically the muscle tone. And you can see there is some activity there showing there's muscle tone. And this is somebody who's awake. And what happens during wakefulness is this pattern, what's called alpha waves activity, that you can see in most of the electrodes. Above the muscle measure is the ECG, which is a cardiogram. And on top of that is the electrooculogram, which looks at eye movements. Now, eye movements are fairly active here because the person is looking around because they're fully awake. So there's this flicking movements continuously throughout, looking around during wakefulness. Now, as we go through sleep, the waves slow down. So if you go back, you can see they're slowing down. And these eye movements, you can see are rolling eye movements, very, very deep rolling waves here in the electrooculogram, and there's some reduction in muscle tone. So this is called stage 1 sleep. And then we go through something called stage 2 sleep, which has got specific markers, which are these big waves here called K complexes. And these spindly type waves, what we call sleep spindles. And these are characteristic of stage 2 sleep. And then we go into deeper sleep. And deeper sleep, or what we call slow wave sleep, is got even slower. So the waves are much slower and muscle tone is lower. So they're large, big waves that tell us that this is slow wave sleep. Now, what happens during sleep is we go through these stages. We go from wakefulness to stage 1 to stage 2 to stage 3. Then we retrace these steps and something else happens, which is called rapid eye movement sleep. So in rapid eye movement sleep, there's flicking of the eyes from side to side, and that's called rapid eye movements. You can see it here. I'll point it out to you. It's called rapid eye movements, where the eyes flick from side to side. And rapid eye movement sleep, the waves are much more frequent. The frequency goes up. So many people used to believe that this was actually wakefulness. So it's also called paradoxical sleep because the waves look very much like somebody's awake. The other aspect to point out about rapid eye movement sleep is that's when dreaming occurs. So if somebody's in rapid eye movement sleep, you wake them up, they're more likely to report a dream. And if you look at the muscle tone, which is a lower trace, you will see that the muscle tone is absent. So what happens during rapid eye movement sleep? We're completely paralyzed, apart from our breathing muscles, our diaphragm, as well as our eye muscles, which is causing the rapid eye movement. And this is because if you're dreaming and you had muscle tone, you would not be enacting your dream. If you had muscle tone, you'd be running down the street, doing all kinds of crazy things that you wouldn't want to do. And that's why muscle tone is absent during rapid eye movement sleep. Now, this is what we call a hypnogram. So we go from wakefulness all the way down to stage 3, and then we retrace our steps and we go to this black area, which is rapid eye movement sleep. And we have these cycles every night. We have 6 or 7 cycles every night of this happening, each about 60 to 90 minutes. As you can see, the rapid eye movement sleep, the slow wave sleep is mainly early hours of sleep. So that's related to our sleep debt, where we pay our sleep debt. As you can see, the rapid eye movement sleep gets longer and longer, the black area, as we go towards wakefulness. And this is why when people wake up, they're more likely to report a dream. Now, sleep is very much related to mood. So you can see this is one aspect where sleep is important to health. Good sleep is important for good mood, good mental health, and mental health affects sleep as well. So this is an individual at the top looking at the hypnogram who has depression. You can see they're spending a lot of time being awake during sleep. You can see this line going across. They're doing that, and they get treated with an antidepressant, and the wakeful time, the time spent awake, is much shorter. So in a way, the sleep can tell us that they're responding to this antidepressant, and that the antidepressants are working. So sleep is a good measure of seeing people's responses to antidepressants, as well as identifying people who have depression, because many people who have depression, sleep is one of the factors that we take into medical history. They have problems going to sleep, staying awake, they have early morning awakening. That's related to depression. So this is slow wave sleep, as I showed you. So what sort of diseases are related to slow wave sleep, or what physiological things are related to slow wave sleep? Now, as I mentioned, slow wave sleep, we have muscle tone. So this is the time when sleepwalking happens. And sleepwalking is actually very familial. So if you have family history of sleepwalking, you're more likely to have sleepwalking. And this occurs usually in the early hours. That's where slow wave sleep is higher, during sleep, early hours of sleep. And there is muscle tone, so you can walk around and are sleepwalking. The other thing that can occur during slow wave sleep is this condition called night terrors. You see this individual's having a night terror, it's a violent night terror. So he's asleep. And you can see he responds violently to that. And this occurs in slow wave sleep, where he has muscle tone and he responds to this night terror. And night terrors can be very common in children, where they cry uncontrollably. And usually it's best not to disturb them because they will settle down. So night terrors occur during slow wave sleep. What about REM sleep? What happens during REM sleep? So the problems we have with REM sleep, we have dreaming and we have loss of muscle tone. So what conditions can be associated with that? One of the most common disorders that are associated with REM sleep disorder is human narcolepsy, cataplexy, which occurs in about 1 in 2,000 individuals. And what happens in narcolepsy is people are sleepy all the time. They have something called cataplexy. I will show you what that is. Basically, the main problem with narcolepsy is that people go straight from wakefulness into rapid eye movement sleep. And that can happen anytime during the day. So they go to sleep. What happens is they lose their muscle tone, and that's called cataplexy, which I will show you what it looks like. They also report sleep paralysis. And sleep paralysis actually is very common. I'm sure some of you have experienced this when you wake up in the morning and you're awake, but you just cannot move because your muscles are paralyzed, and this settles down, and then you're up and up again. Or they can have hypnagogic hallucinations, which are when they wake up, they have this dreamlike state. In a way, it's like being in a REM sleep, where we dream. And of course, because they sleep during the day, they have disturbed nighttime sleep. And narcolepsy has got a very rich history. The term the description of the disease was first by Westphal, and then in 1980, Jellineau described narcolepsy, and for a long time it's called jelly nose syndrome. And Lowenfeld basically called cataplexy, which I'll show you what that is. And then it was found that actually narcolepsy occurs in dogs in what we call an autosomal recessive genetic manner. So if the two dogs carry the gene and they mate, then about a quarter of their offspring will have narcolepsy. And in 1992, it was associated with something called HLA-DQB10602, which means that actually there's an immune element to narcolepsy. There's some immune dysfunction that allows the immune system to attack particular cells that cause damage and result in narcolepsy. And these cells were found to be located in the hypothalamus, where we discuss is the seat of wakefulness and sleep. So it damages some neurons called hypocretin orexin neurons. And we now know that human narcolepsy is because of damage to these neurons and lack of hypocretin. Now, narcolepsy occurs usually in children and adolescents. As you can see, the peak occurs in adolescence, but the problem with narcolepsy is very badly recognized. So people get diagnosed, these adolescents get diagnosed up to 10 years later than when they first present with sleepiness. And that's because many people say this is an adolescent, they're not sleeping correctly, or they're lazy at school, and this kind of thing. But if somebody has cataplexy, that is what we call pathognomic, which means that it actually is a real marker that somebody has got narcolepsy. Now, this is to show you what happens in narcolepsy here. So this is a person who's allowed different people, one who doesn't have narcolepsy, the normal subject, and one who has narcolepsy, and they're given several opportunities during the day to go to sleep at 10 a.m., 12 noon, 2 p.m., or 4 p.m. As you can see, the subject with normal sleep does not go into any sleep. It's very hard to get them to sleep, and sometimes there's no sleep. Whereas what happens in the narcolepsy patient, they go from wakefulness quickly into sleep. This is called short sleep latency, and they go straight into REM sleep. So in a way, what happens to people is they're awake and they go straight to REM sleep with muscle paralysis, which is called cataplexy. And we know that this is the area of the hypothalamus. You can see these are the neurons called the orexin hypocretin neurons. And it's believed that there's an autoimmune attack, that your body attacks these neurons and they disappear. You can see in the narcolepsy model, narcolepsy brain of a human, that these neurons are damaged. And if you measure hypocretin levels that measure this protein produced by these neurons, they're very low in patients with narcolepsy compared to those who don't have narcolepsy. Now, this is what cataplexy looks like. Now, cataplexy is loss of muscle tone. People are conscious. So this is a child, they're trying to tell it a joke to make it laugh, because cataplexy occurs during joy and laughter and happiness. So they're telling this child a joke. They're saying, why did the skeleton not go to the disco? It's because he had no body to go with. You can see it's laughing. You can see the jaw dropping, the muscle tone going in the child, and you can see, and that's called the cataplexy episode. Now, the child is completely awake. They're not unconscious when cataplexy occurs, and usually they fall in a way that doesn't hurt them. But of course, if this happens in the swimming pool, then it's very unsafe. So that's cataplexy. And this is cataplexy in dogs. So you can see dogs get excited when they play, but also when they're provided wet food. So these dogs are playing. This is Emmanuel Mignot from Stanford, who was one of my mentors. So these dogs are playing, and you will see that their legs give way as they get more and more excited. So this one's legs giving way. That's called partial cataplexy. And as they play more and more and get excited, they lose their muscle tone. So you can see their muscle tone's gone. And this is a cataplexy in a genetic model of the dog. So these dogs have an autosomal recessive inheritance. So this one you can see is conscious, fully awake, but has got no muscle tone apart from its breathing. And like I said, the eye movements. And they wake up and then they play again, and the cataplexy occurs. And these dogs were for a long time a really good model of narcolepsy, because you could actually really understand the disease. And now we know why the disease occurs because of this lack of these neurons. And the dogs really provided that information to be able to decipher that. Now, moving tack a little bit from narcolepsy, another illness that's more common in REM sleep, although it occurs throughout sleep. As I said, in REM sleep, the muscles are relaxed and our breathing changes during sleep as well. So as you can see, the air has to come in through the nose or mouth, and there's very narrow passages here. So if there's any excess tissue, like a big tongue or fat around the neck, usually with obesity, what happens is airway narrows. And that results in a condition called sleep apnea. So this is normal breathing. This is called snoring, where there's, as the air goes through, there's vibration in the upper airway structures that causes a noise. And this is obstructive sleep apnea, where the airway actually closes. And it's a very common condition. So the airway is closed, there's no air going in or out, there's respiratory effort. And what happens in this condition is people stop breathing many, many times during the night, from 30 to 100 times per hour, and their oxygen levels drop, so the brain is not getting oxygen, and they wake up without realizing it. So during the day, they're sleepy and are at risk of having accidents, but we also know that sleep apnea is important in cardiovascular disease and metabolic dysfunction. But let me show you what sleep apnea looks like. So this person's snoring, loud snoring. And this is an apnea. You're completely not breathing. No air going in or out, not even snoring enough. And then you can see effort. So the chest is showing effort, the band around the abdomen is showing effort. The person's trying to breathe against the closed airway. And like I said, it's very common in obesity. So the oxygen levels are now dropping and the brain is not getting enough oxygen. So let's see what happens. He's trying to get air in, and then he wakes up and is breathing, but he's not awake, as you would see, but we can see it on the electroencephalogram, which is the EEG, that he's awake. Now he's going to another episode. So this is a quite serious condition, and it's very common in obesity. Obesity is one of the drivers of this, but of course, if there are any abnormalities with this, with the upper airway, that can also result in sleep apnea. Now, sleep apnea mainly occurs it's more common in men. It occurs with older age, and it gets more common in women in postmenopausal age. It can occur in children, and is usually related to tonsils. So a child should not really be snoring regularly. Unless they have a cold or something. So if a child is snoring regularly without having a cold or anything like that, then that's sleep apnea. And that can result in poor school performance as well as cardiovascular problems. Sleep apnea, like I said, obesity is a key driver of it. Of course, upper airway abnormalities also can result in many problems. So there's neurocognitive dysfunction, where because of lack of sleep at night, waking up many, many times, people are sleepy during the day, so they can go to work and be present at work, what's called presenteeism, but not be able to perform as well. And workplace accidents are common, car accidents. They can result in mood changes such as depression. The main problem we worry about from a medical point of view is hypertension, cardiac abnormalities such as arrhythmias, abnormal heart rhythms, heart attacks, and stroke. And they also report waking up with headache, acid reflux disease because of the pressure on the abdomen pushing against the stomach and esophagus. There's an element of sexual dysfunction, and of course, reduced quality of life. We also know that sleep apnea is related to metabolic abnormalities such as diabetes and worse diabetes. Now, how common it is, depending on the study we look at. So this is a study from Wisconsin. So if you look at the far right part of the curve, they're reporting about 9% in community in the men and 4% in women. In Spain, they're reporting 14%, 7%. So it depends on the community that we look at. If we look at a type 2 diabetes population, it can be up to 80% of people with type 2 diabetes have got some element of sleep apnea. So it's a very common condition. And the telltale sign of somebody with sleep apnea is that somebody observes somebody stopping breathing at night. And that's a telltale sign. What's called a witnessed apnea is a telltale sign of sleep apnea, and that needs to be investigated. What about sleep and alertness? So many of us are burning the midnight oil and staying up really late and waking up early. So we develop this sleep debt. And sleep debt can result in loss of alertness. And you can see these are called microsleeps here. Somebody driving in a motorway at night, they may be going into these microsleeps that can result in a serious car accident. And the fact is we're really bad at telling how well we slept the night before. So if you ask someone, how well did you sleep? So I had a terrible night, but actually they slept really well if you look at them in the sleep lab. And some people say, actually, I slept really well, but actually they had a really poor sleep. And that can result in car accidents. And car accidents happen usually in the afternoon and also in the early hours of the morning. And that's the time when the circadian drive is really low, like I showed you in the process C and process S. So when the circadian signal is low and sleep debt is high, these sleep episodes occur, and that's when accidents happen. This is what happens to somebody driving. So you can see he's sleepy, his eyes are closing up and rolling around, and he's going to sleep. And you can see the consequences of this are fairly enormous. So if you have an accident like this, it not only affects the people who are involved in the accident, but actually also costs the economy a lot of money because you have all these people waiting up to get to work. And then you also have to clear it up. So the cost of this is really enormous for the individuals affected because of sleepy driving. So it's really important to pay attention to sleep apnea as well as lack of sleep while driving and particular times of driving. Like I said, where the circadian signal is particularly low. Of course, you may recognize this is the Exxon Valdez disaster that resulted in environmental damage, which was a major oil spill, and this was related to sleepiness. And there's some element of the Chernobyl disaster that was also related to sleepiness. So the consequences can be really enormous. So we're ignoring sleep, and we're sleeping less and less and not really worrying about it, but actually can have really dire consequences for people if accidents occur. Another common sleep disorder is sleep apnea. Sleep apnea is basically the different forms of it, but it's due to people report inadequate or poor quality sleep, difficulty falling asleep, frequent awakenings at night, waking too early and not being able to go back to sleep and feeling unrefreshed or having non-restorative sleep. Now, insomnia is very common. This is data from the States. About 40% of American adults have it, occasional insomnia, and about 10 to 15%, 1 in 10, has it on a chronic basis. And those who are at most risk are women, older adults. As people get older, they have more tendency to insomnia, and depression is also a driver of insomnia. And there are different types. There are acute insomnia where, for example, you have jet lag or you have an acute illness or there's some stress going on, and it's usually transient that settles down. Or it can become chronic when it lasts longer. And these are very difficult to treat. There are different approaches of doing it, and usually there's a combination of cognitive behavior therapy, and we're aiming that very few people will need medication to get to sleep. Now, what about sleep and obesity? This is an area I've been interested for a while. And this came through the idea that when you look at both men and women adults and compare 1985 to 2004, this is the percentage of men and women at different age groups sleeping less than 6 hours. And you can see that comparing 2004 to 1985, this is the US, that more people are sleeping less than 6 hours. So what does this really mean? Because if you look at the same time span of when obesity is occurring, obesity was on the increase in the United States and across the world, and also diabetes was also on the increase because of the because of it being driven by obesity. So can the two be related? Now, this is a study, and there are many studies now, but I'm going to focus on called the ASPAC study, which also is called the Children of the 90s studies. It's a study in Bristol where I trained, and they recruited 13,000 pregnant women and their children, and they followed them up. And one of the questions they asked in the ASPAC study were the factors at age 30 months, 2.5 years old, for a child that would predict that child becoming obese at age 7. And 25 factors were looked at, and 8 factors were significant. So early body mass index, if the child is more obese, they're more likely to be obese at age 7. If the parents are obese, if one is obese, is less than when both are obese. TV watching at 3 years, birth weight, catch-up growth, early maternal smoking in pregnancy was related to more obesity at age 7, but also sleep at age 30 months. So that means the shorter the sleep of these children at age 30 months, the more likely they were going to be obese at age 7. And this is remarkable. Now has been shown in many, many different studies that shorter sleep is associated with obesity. And this is data from Qatar, looking at sleep time here on the bottom for each of these, look at body mass index, BMI, waist circumference, which is a measure of body fat, fat percentage, measuring fat percentage, and fat mass. You can see there's a linear relationship that as we go to shorter sleep, there's greater likelihood of having higher body mass index, higher waist circumference, fat mass, and fat percentage. This is data from primary school children in Qatar. So this has been shown several times across different studies. And now we strongly believe that sleep is one of the lifestyle factors. We have nutrition and diet, and you have physical activity, and sleep is a third lifestyle factor. Now, how does sleep cause this problem with obesity? We were interested in 2 hormones. So leptin is released by your fat cells to tell your hypothalamus that you have too much fat, you should stop eating. But the problem with leptin is obesity results in higher leptin levels. That means the leptin levels are not working. They're not telling you not to eat. So leptin is much more important when it's low, because it's telling you you're starving and telling your hypothalamus you're starving and you should go and eat. And ghrelin is released by the stomach and it tells your hypothalamus, I'm hungry now, so go and eat. So low leptin is starvation, so you have to eat, and high ghrelin tells you you're hungry, so you have to go and eat food. So how is sleep related to these hormones? And we did a study with a Wisconsin sleep cohort where I showed you the prevalence of sleep apnea. We looked at the sleep of these over 1,000 individuals. And what we showed, if you go from 8 hours of sleep to 5 hours of sleep, the body mass index was higher. Leptin levels were lower, showing starvation, and ghrelin levels were higher by about 15%, showing hunger. So just to put this into perspective, if I put you on a 1,000-calorie diet a day and you start losing weight, your leptin levels will go low, telling your body you're starving, and your ghrelin levels will go high by the same amount, telling you you're hungry. So for the first time, we demonstrated in a large population that actually shorter sleep is associated with obesity and changes in metabolic hormones that drive hunger and appetite. And this was the first study to show it, and this was in 2004. And this is the beginning of people understanding that actually sleep is really important in managing our metabolism. And it makes sense because, like I showed you, where sleep is regulated is the hypothalamus, the center of regulation of the body, where everything is interconnected. And that's why sleep is so important. So now we've been exploring how sleep loss could result in obesity. As I showed you, it's low leptin, high ghrelin, but other hormones are also affected that affect metabolism. And this drives hunger, selecting the wrong foods, and also affects our energy expenditure. Also, sleep loss can result in tiredness, so we're less active during the day, and that can drive obesity. Now, of course, if you're awake longer, you have greater opportunity to eat. So unlike the totally sleep-deprived rat, we have access to a fridge where we can actually go and get very appetizing food, or we can order it through a takeout service. So now you can see that sleep is now the third lifestyle factor, and it's absolutely important to pay attention to sleep because we know it drives hunger and appetite and can affect our activity levels. So diet, physical activity, and sleep are the cornerstones of our health. And sleep, as I said, is a third of adult life, as half of adult life, and hopefully I've convinced you that sleep is also important in metabolic function. We also know that shorter sleep is related to hypertension and increased risk of cardiovascular disease. Now, how do we improve sleep? It's important to pay attention about improving sleep. And most things like in life, in terms of eating and sleeping, requires regular schedules. So regular schedules are really important, but also your bedroom environment is absolutely important. So being in a dark room, it's important to use blackout blinds. The room has to be cool, but not too hot or not too cold. It has to be quiet. And this is one of the reasons people with who are night shift workers cannot sleep during the day, because they're trying to sleep, but there are things going on. There's children about, there's people delivering post, knocking at your door. So it's not quiet. So they're sleep deprived. Avoiding electronic devices in your bedroom. We have done a lot of research now that has shown from most age groups, from adolescents to adults, that having electronic devices in your bedroom can actually affect your sleep, not only because of the light emitted by the devices, but also because when you're curious or your mind is working overtime, or you get bad email that will affect your mood, that will significantly affect you going to sleep. Avoiding caffeinated drinks, including those energy drinks near bedtime. So if your bedtime is at 10 p.m., you want to stop drinking coffee around 6 p.m. because that can affect your sleep. Alcohol actually puts people to sleep very quickly, but actually disturbs sleep because the sleep is not consolidated. I mean, the sleep is not continuous. It's broken sleep. So alcohol is to be avoided near sleep time. Keeping regular sleep-wake schedules is absolutely essential. So it's important to keep timings. Your body works so much better. The circadian system regulates our clock timing in terms of how our body functions. So it's really important to keep those regular sleep and wake schedules. If you're worried about something that can disturb your sleep, so spend time thinking about it a few hours before going to bed and trying to resolve and come to a solution. We talked about devices, no emails, taking a warm bath or a shower helps, because this graph shows you that as we go to sleep, our temperature drops. So if we raise our temperature through having a warm bath or warm shower, then we're more likely that our temperature is going to drop gradually and we're going to go to sleep. So Bill Dement, who is what we call father of sleep medicine, who was privileged to know from Stanford, he passed away unfortunately last year. He said a large sleep debt does not go away spontaneously. It does not diffuse out of the nervous system. It can only be reduced by extra sleep. And many of us are carrying this sleep debt. And we think and that's why we have this sleep debt during the week, and we try to make it up over the weekend by sleeping longer, but it's not enough to do that. Because even what happens on the weekend, people want to be even more active, and they have children who wake them up. So it's very hard to actually pay that sleep debt unless you get good regular sleep. So to conclude, sleep is complex. I showed you that you don't die during sleep, that many things are happening. The brain's active as measured by the EEG. It's a basic biological need. I demonstrate to you there's not a waste of time, and fish do sleep. Many different organisms do sleep, and it's essential for our health. I showed you that good sleep is related to obesity, and that's also data to show it's related to hypertension. I showed you disrupted sleep, like sleep apnea, can cause problems in terms of performance, driving, accidents, safety. Of course, poor sleep is related to quality of life, depression. Sleep deprivation has serious negative consequences. So we're living in a sleep-deprived society. and this 24/7 society that we've inherited is being detrimental to our health. So we need to take control of that and ensure that we're getting adequate sleep. Establishing healthy sleep practices prevents sleep problems and promotes optimal sleep. Signs and symptoms of sleep difficulties need to be identified. I showed you several sleep disorders and how they relate. And it's really important that if you are aware of having any of these symptoms or anybody you know who has these symptoms, to actually tell them or arrange for them to see a specialist to do that. In fact, I remember when I first arrived in Doha many years ago, I had to stop somebody who was driving during traffic and sleeping because of what it turned out to be sleep apnea, because he got referred to a sleep service and was diagnosed with severe sleep apnea. And it could have caused a very serious accident by driving while sleepy. I would like to thank all the people I worked with. I've been very fortunate because I'm an endocrinologist by training. I've also ended up training in sleep research at Stanford, where all the narcolepsy dog colony was, and some of the discoveries were made in terms of narcolepsy, and also some of the founding fathers of sleep medicine, where I learned a lot from them, particularly Emmanuel Mignot, who I worked with very closely, who has done some of the significant work in terms of narcolepsy, showing this is potentially an autoimmune disease. We're getting more evidence of that. I worked with the Wisconsin Sleep Cohort Study, Terry Young and Diane Austin, who's really set the agenda in terms of sleep apnea that everybody followed. It was one of the major publications that did that. I was lucky to work with Bristol with people, particularly Peter Fleming. Peter Fleming was one of the people who actually showed that cot deaths were related to putting the babies on their bellies. And this saved many lives, this intervention, where we now know that it's better for babies to sleep on their back. John Henderson, who was involved in the ALSPAC study, and we did some work with the ALSPAC study. And of course, I've been funded through several organizations that have helped me through the years and allowed me to share some of my knowledge with you. Thank you for listening.
Okay, Dr. Taheri, thank you so much. It's been wonderful. I hope, also our participants have really, I'm sure they've benefited a lot from the session. And thank you again for this very, very important topic. And as we go along the lifestyle medicine movement, we of course want to focus on all lifestyle behaviors, and sleep being really, really key element. So thank you again for being here with all of us, and my gratitude to you.
Thank you.